we will talk about how preventative risk management can help reduce vulnerabilities in your infrastructure and decrease the average age of open vulnerabilities by up to 89%. With that said, let's start with, and before we start talking about this topic further, if we can just help answer the questions that will soon appear on your Zoom screen, your answers will help us understand how these situations affect you and your organization. An estimate is okay. Thanks. Thank you, everyone, for answering those questions. Actually, the second poll, we'll have that raised for the next slide when we have that. So, Andrea, if I can ask you stop the poll 2. And so before we delve into that piece, let's talk about risk management and that larger picture. So risk management is a big challenge for public organizations using cloud services due to increasing cyber attacks and service disruptions. So last year's incident with United Healthcare Group, that highlighted these risks, leading to a material impact and a decline in stock value. Additionally, SEC requires public traded companies to disclose their cybersecurity risk assessments annually via the 10K and then report material incidents within 4 business days via the 8K that we have here. And really, it's what the stuff that we're talking about here right now is all in relation and driven by this need from the SEC. So in relation to that, if we talk about asset management involves overseeing an organization's devices, data networks, and components critical of data handling. So understanding your assets is critical for identifying risks, especially since the SEC requires it. I would go on and say that your biggest risk is not knowing what your risks are. Many organizations, they struggle with asset management due to incomplete inventories and network diagrams, and particularly in dynamic cloud environments. So achieving this visibility is the first challenge, followed by the need to continuously update information for security and compliance. And that can be overwhelming. So traditional methods are often manual and error prone, and that complicates the process. So organizations, what they need to do is start prioritizing on tracking infrastructure and applications, and automating the infrastructure would enhance the security and posture of hybrid cloud environments. So many organizations nowadays are adopting a hybrid cloud strategy. And really, that's combining services from various cloud providers with their physical data centers to achieve their business goals. However, this shift, it presents challenges, particularly in securing and managing the infrastructure and applications. So according to the HashiCorp State of the Cloud Strategy Survey, security is critical for the success in a multi-cloud or hybrid cloud environment. And so failure to maintain security will impede business progress. So organizations, they need to start addressing outdated processes, or rather processes which deem outdated in the context of hybrid cloud, right? And to implement that hybrid cloud effectively, key issues include things like a lack of centralized platform for managing infrastructure across cloud providers, uncertainty in enforcing security and compliance policies with limited visibility, fragmented workflows that increase the risk of errors and hinder scalability. And so when organizations, they don't address these security challenges or update their infrastructure regularly, then inconsistencies start to arise in when you're trying to enforce security and compliance, holistically speaking. And that leads to more vulnerabilities. And so some of the key challenges that include are a higher risk of security vulnerabilities during initial deployment, difficulty finding vulnerabilities in current infrastructure, and then long time and long lead times to go ahead and fix these vulnerabilities. So according to IBM's cost of a data breach report, vulnerabilities remain open for an average of 277 days. That's just over 39 weeks. And even when companies find or detect vulnerabilities, they often spend much time and money trying to fix them. So consider how organizations manage vulnerabilities and patches today. Vulnerability and patch management, in this case, would be in finding, prioritizing, reducing vulnerabilities, as well as taking the steps needed to fix them. And today we'll focus on the preventing and reducing infrastructure vulnerabilities. With that said, we can have you answer the questions on your Zoom screen for the second and final time now. Oh, looks like we've got everyone as filled in the second one as well. Great. All right. Thank you. So with that said, keeping your organization's infrastructure secure means identifying and fixing vulnerabilities in cloud-based and on-prem systems. Unfortunately, many organizations, they overlook areas where vulnerabilities can exist. And a key area to focus on is compute images. They form the backbone of modern computing as we see it today. And that includes your Amazon EC2's AMIs, your VMs, and Docker containers even. And it's important to note that 87% of container images used in production have critical vulnerabilities. 60% of data breaches are tied to unpatched vulnerabilities. If organizations don't update their images and cloud compute management practices for hybrid cloud environments, they risk exposing sensitive information as well as exposing the weaknesses that may reside in some of these assets. And so managing compute images and VMs without a solid plan isn't enough. And the main problems from not monetizing and continue to pursuing a traditional reactive approach to handling vulnerabilities and updates include human error from manual and live implementation, and there's gaps in skills and a lack of shared knowledge that lead to inconsistent processes and handoffs. Relying on these human intervened manual methods to set and maintain standards, they result in discrepancies in the security and compliance and performance of these compute systems. Second is the lack of tracking and the expiration of non-compliant compute images. So without a sound system to monitor all infrastructure, it's hard to find assets at risk. And organizations don't have a standard process for setting end-of-life dates, leaving these out-of-date, vulnerable, non-compliant images in their system. And lastly, the long lead times for remediation. Many patch management methods, they depend on manually updating servers through a patch server. This approach is disruptive, and it requires scheduling service downtime during multiple change windows. And so together, these three issues that we see here on your screen amount to a material risk for organizations. And that's really, that material risk is very important in the topic of cyber materiality and the SEC discussion that we had earlier. So to effectively manage software updates and minimize risk, we're recommending to adopt an industrialized approach to patch management. So Mandiant research shows that a vulnerability takes an average of 32 days to exploit. So to mitigate this risk, we're suggesting to establish an automated process that leverages immutable images and compute instances. And it can be achieved by updating images every 30 days and then re-provisioning compute instances to use those latest images. And so when you implement this strategy, all images and compute resources remain up to date and protected before any vulnerabilities can be exploited. So what makes our approach different? Many cybersecurity solutions focus on finding vulnerabilities in systems and then alerting the technology owner. These days, they may even add a flavor of AI to provide the context. And that's great. That's really helpful, especially for audits. And our approach, it doesn't conflict with this. We, in fact, provide integration plugins for these tools and platforms. An example of that would be like Palo Alto's Prisma Cloud, which you can learn about actually in an upcoming webinar we'll be hosting soon. IBM reports that it takes an average of 186 days to find a weakness or find a vulnerability, and then an additional 91 days to resolve it. This means, and on average, a vulnerability can remain open for 277 days across your digital assets. So what sets HashiCorp apart is really our proactive approach. We aim to stop vulnerabilities before they enter your systems by thinking about secure before it leaves the door. We shorten the time to vulnerabilities that stay open and reduce the risk of exploitation. And it's critical to address this issue from both angles. And by doing so, you can avoid the average 32 days to exploit a vulnerability. And so HashiCorp, they offer a platform that helps implement a system for scaling. And that includes creating infrastructure and machine images, deploying these hybrid cloud resources, and managing the infrastructure lifecycle over time. So if you start with Terraform, well, that's a tool, as most of us know, and it uses infrastructure as code to manage your entire infrastructure. But how does it work? Firstly, Terraform uses infrastructure as code to create a repeatable and automated workflow. And that ensures guardrails are enforced. It speeds up cloud resource provisioning, and it reduces the need for those human intervened manual checks. Secondly, having a system of record and the standardized workflow that gives you clear visibility into your infrastructure. And thirdly, those lifecycle management features and tools for managing cloud resources, like continuous checks with policy as code, they help you keep track of and control all of your resources. So like Terraform, that helps you manage infrastructure through code, Packer and HCP Artifact Registry, they do the same for images. And this makes the idea of images as code accessible to everyone. And with images as code and Artifact Registry for all your images and tools to manage their lifecycle, can together help you simplify your image management process. And so if we bring those two together, these components, they create a comprehensive workflow for managing immutable images and infrastructure lifecycle. When images are built using Packer, metadata is published to HCP Packer, where standardized versions are available. These images are then discovered and validated in HCP Terraform. HCP Terraform references HCP Packer to ensure compliance by validating that it uses approved images. Ultimately, this approach enables us to deliver secure and compliant infrastructure at scale consistently. So with this workflow, we provide critical value for your business. It reduces the risk with immutable images, right? Avoiding human error during that live server setup by shifting to a more secure, consistent, and rapid approach. By gaining clarity with a system of record, so knowing exactly which images are in use and where they are. Monitor images across all cloud and on-site and on-prem environments for one place. And lastly, managing life cycles, right? Setting those expiration dates for your images to make sure old and insecure or non-compliant images are removed regularly. So before I show our opinionated solution for vulnerability and patch management, let's review some key features critical to its success. So HCP Packer features a scheduled revocation. It allows you to control when images are marked outdated or retired. So that whole end of life process that I mentioned earlier. Now, this process automatically removes old or insecure images, reducing security risks and limiting potential vulnerabilities. Regularly revoking images, ideally on a 30-day cycle, that ensures there's compliance with regulatory requirements for preventing the use of outdated images. Now here, just a note, by no means when we say outdated images, would they necessarily have vulnerability or not? But it's better to stay safe. And if we have that mature process where you're regularly updating every 30 days, then the cognitive load to understand whether some of these vulnerabilities exist in images or not is vastly reduced. Why? Because you're not focused on that anymore. You're focused on reducing the timeline or how long a vulnerability can be open there. So it establishes clear rules of, for image exploration, and it streamlines the management of immutable infrastructure. And it helps your artifact registry to be clean and up to date while providing a transparent method for retiring our images. And without this revocation plan or a strategy around removing these and revoking these, outdated images would be deployed, they would remain there, and it would lead to those vulnerabilities and discrepancies. And scheduled revocation, it mitigates this risk by ensuring that only current approved images are available for maintaining a stable and secure infrastructure. And very closely aligned to this is inherited revocation. And this is quite important, especially for organizations where we're trying to help them with their maturity level and where we want to have and empower developers to start building their own images, which will be considered as child images to parent images. And so for this effective vulnerability and patch management, inherited revocation becomes critical. It ensures when a parent image is revoked, all related child images are also automatically revoked. And that prevents compromised or outdated versions from being used without manual tracking. And this is actually quite hard to do today. Trying to track dependent images is really hard in large environments. Right? But inherited revocation, it simplifies this process. It enhances overall vulnerability and patch management by automatically removing those remote images from the ecosystem. Now, combining Terraform's drift detection with HCP Packer provides a robust framework for managing vulnerabilities and updates. A drift detection ensures your infrastructure aligns with the intended setup, preventing outdated settings. Now, continuous validation here by Terraform identifies and fixes those deviations from secure configurations. So while HCP Packer ensures all instances are built from updated, secure baseline, eliminating drift. Now, this process, it supports compliances with standards like CIS benchmarks, PCI DSS, and HIPAA, as any drift from compliant images is quickly detected, logged, and audited. And here we have it, our take on opinionated approach and solutions to vulnerability and patch management, emphasizing that your images are updated with the latest patches approximately every 30 days, and that VMs are replaced with those latest images. The specific workflow and technical details that will be discussed with an opportunity to get hands-on in a follow-up workshop scheduled for next month. And with this said, I'm just going to go ahead and play you a demo and which my colleague Carl already had recorded, and I'll walk you through the practitioner experience of how you'd roll out compliant images. Okay. And the image build template here is the only thing that needs to require updating. I'm just go ahead and reach. So what we want to do here is we're going to start following the steps to track those images that are non-compliant. And so we're going to head over to the Packer registry here. And here we are seeing the list of cloud resources that when you click on them, you start to see all related parent and child images in relation to this image artifact that you'd have. From here, though, what we want to do is start going into channels. And in channels is where we start to actually have dynamically assign image versions to a channel. And then the channel becomes a reference that in HCP Terraform, you can reference and use, and it will point to these versions. So here, when we walk through, what we want to do is show you, okay, say in production, we can see version 2. In this scenario, let's say that version 2 has a vulnerability. And so what we want to do here is then we want to show here actually the production channel. Let's go ahead and update it to version 3. And that's the latest version, which is compliant, and version 2 is now non-compliant. Quick note here, as you can see, there is a revocation that's taking place here. And this is a manual revocation, what we're showing you. And this is a reactive approach. The proactive one, actually, which is the scheduled revocation, that will happen automatically. Now, moving on to the HCP Terraform, where we can actually look at the Explorer aspect. Here we can start to see now all of the workspaces that have been drifted, i.e. from that drifted text, it will start saying, these are the workspaces that are using non-compliant images. Right? And then we could go into each of these workspaces and we can start to see the health check. And we'll see that shortly coming through now when Kyle decides to click on one of the workspaces. And so here you can see there are a myriad of information that you can see for each workspace. But what we want to see here and focus is on the right-hand side where it says health. Under there, we can see a drifted resource, which is drifted, and this is basically indicative of the image that it's supposed to be using. So the production reference that it had, obviously it was using version 2. We've gone ahead and updated to version 3, and we will see that when we click on that. But you can also see that all of the resources that are used for this workspace that are there as well. By the way, drifted text will also show other pieces of drift. But today we want to focus on the drift away from compliant images and how these are vulnerable. So when you click on this drift, you can see that actually this EC2 instance is what's been drifted. And when we expand upon it, we start to see basically there is a discrepancy on the AMI. And what we're showing here is that what we need to replace it with the latest image that we've published, and the old image is now considered non-compliant. Now what we can do is we can start to also mediate from here, right, at this point. And how you do that is by triggering a new run. And when you trigger to the new run, you're updating to that latest image. And so here it's going to start to run a plan. And in this plan, you start to see, as you see with Terraform plans, we see that it's planning to then use the new image and replace the VM to be re-provisioned with that new image. So remember when I was telling you around, we have the continuous update of images. Now this is the continuous re-provisioning of images. One other thing you'll notice here is now that whilst Carl is scrolling down here, is that we can start to apply run tasks and also policies, like OPA policies and Sentinel policies. And from there, we can start to also validate and verify that even this latest compliant image is that in accordance to the HCP Packer. So the HCP Packer run task, at that point, it will ensure that it's aligned to a channel and an image that hasn't been revoked. But then there are other run tasks. And the Palo Alto Prisma Cloud example is a good example of where you can have a run task that will do the scan, and it will show you the scanning of the images to show that if there were any other vulnerabilities that it may have existed in that new image. Carl will obviously just scroll down to OPAs and Sentinel policies, but with those Sentinel policies, there are other things that we can start to do as well that can enhance this kind of image continuous replay process. Now, not only obviously in this example where you can start to govern what type of EC2 instances are deployed, but we can also start to use Sentinel policies to validate the build environment. And it's not showing here in this demo, but now with the new SBOM feature that we've deployed in Packer, we can start to validate that the build environment in itself is compliant, and it will start to produce details like around the GitHub actions or the GitLab actions when they're building that Packer image. So now, in this case, we'll show that Carl will go ahead and do a confirm and apply, and it would add a comment here, at which point you can add these. If it was a reactive piece, you can add a comment in relation to the incident or the vulnerability, or you can add a comment here that will be in relation to a continuous change around that updated image piece and that image lifecycle. And it's going to go ahead now and do that kind of run. The other thing is here, this is obviously showing one workspace at a time. There are ways where we can start to look at multiple workspaces, or there are ways where you can start to create a notification if you weren't, say, the workspace owner, and that the ownership of these workspaces were more distributed to be more with those kind of application owners. So with that said, I kind of want to now really open the floor to questions. If there are any questions or Q&A that you have, I'm happy to answer, and we have a team here on the call that can help answer as well. I'm just reading let me just read this question that's still open. So it says, with revoking all children of an image, how do you deal with derived images with applications that have not yet been regenerated on the next version and are still in use? So I saw an outage caused by having the base images revoked before the application team generated the new version. Auto scaling failed due to the lack of the image. Now, this is a good question, and this is something that we will go into detail in the workshop. But there is a inherent dependency that we can't see in this piece here. Let me see if I can just go back to the diagram. If we look at this diagram, and I'm trying to answer your question here, right, is if we, and as part of this opinionated workflow, there is a people process that we need to help establish. And that people process is essentially where you must have a release cycle, 2 release cycles where there is a 30-day cadence of these release cycles, and that would essentially have a cascading effect. So the first release cycle, which is going to be essentially the base image owner, and they will be updating regardless of whether there was a vulnerability or not, but updating with the latest patches and versions. Once they've gone ahead and updated that, you want to then send a notification out to the child images or the owners. But regardless of the notification or not, you would have if we do a where it's basically the cadence is staggered, then the next cadence, and in that 30-day cycle, let's just say beginning of the month is the parent image owners, middle of the month is your child image owners. But there needs to be an established people process where they will need to continuously update those application images. And it can't be, oh, when I get a chance, I'll do it. Rather, it needs to be a very strict process that needs to be fall in place. There are other ways we can start to then create those notifications when they haven't updated. But once they do that updating of image, the continuous update of the image, then the revoke will then revert to the latest image itself. From an auto scaling perspective, again, you're right. This is the image that's revoked. So actually, let me just think about this for a second. So auto scaling, I don't think it would, because when the image is revoked, the image is revoked in Packer. It doesn't necessarily revoke it in AWS. And because auto scaling takes place outside of Terraform, I'm struggling to understand why that would have felt, or is it because actually there was no image to begin with? It should revert back to an image. So when you do a revoke, it would revert back to the next available channel or image that's available. So in our case, as we showed in the demo, we would make available the latest image first if it would go ahead and revoke. Hope that answers your question. I'll just go ahead and read the second open question here. Does HCP Packer allow for multiple accounts in AWS? I.e., what if the parent is in one account and the child images are in other accounts? Can this occur? And if so, is there specific configuration required on the accounts or AMIs to achieve this? I'll ask the team on the call here if they have knowledge on that AWS aspect and the support for multiple AWS accounts. Is there anyone here on our call that can answer this live? Right. So what I'll do is I could take.
Sorry, hi Adil. I was just trying to read through this question, and the Packer is, as you just mentioned, is it's a build image process management and all, and you can manage multiple accounts, multiple regions within the same account and all that. So it's and one of the Packer images can be used as a base image for the next image. As long as the base image is available in that particular region, then you will be able to use it, or in that particular account, you will be able to use that process. But the only dependency is AMIs are very, very specific to a particular account and a particular region.
Okay. So I just want to add to this as well. Thanks for that. I want to add to this as well is that so what if the parent is in one account and the child image is in other accounts? That is possible, and that can work, right? Where the parent image is published in one account, and so the child account, and the whole publishing process of that child image will happen in that child account. So when you do the Packer build, you can point towards that other AWS account. I would say here though is that the IAM permission in AWS natively, you just need to make sure that there is that cross account IAM permission that's available there. That's the only thing that I wanted to kind of highlight as well. And again, I hope that answers the question for the anonymous person. Any other questions? Well, if there's no questions, then I'd like to thank everyone that's attended and been patient with me. And I want to kind of hand over back to Andrea. Thank you.
Thank you, Adil. What a great presentation. And yeah, as I said before, we have recorded this webinar and you will receive that recording via email post-processing. And I just want to thank everybody for their time and for joining today. I hope everyone has a great day and we'll see you soon, hopefully. Bye.